Okay, let's do this next example. This says differentiate the following functions. I have these formulas up for you so to see. It's a good idea to bring your own formula sheet when you're doing the questions, but every single time write down the formulas to practice it, okay? F of x is x squared plus cotangent x. We need to find the derivative of the function. X squared's derivative using the power rule. 2 comes down, x2 minus 1 plus cotangent x's derivative is negative cosecant square x. So basically 2x minus cosecant square x. Okay, that's your first example. Let's do the next one. Here y is equal to x by 2 minus tangent x. Okay, so for this one, really, you need quotient rule also. So I'm going to write down the quotient rule. If we have y is equal to u by v, then derivative of y, denominator square, numerator's derivative times denominator minus numerator times denominator's derivative. Okay, let's use this here. Denominators square, derivative of numerator times denominator as is minus numerator as is times derivative of numerator. Derivative of x is 1 times 2 minus tangent x minus x. Derivative of 2 is 0 minus derivative of tangent is secant square x. Oh, we don't have that formula here somehow. Okay. Derivative of tangent is secant square x. I'm going to write it here to remind you. Okay. Divide the whole thing by 2 minus tangent x whole square. Let's open this up. 2 minus tangent x, negative, negative, positive, x, secant square x, divide by 2 minus tangent x whole square. Okay, let's look at this next example. We have h theta given. You need to find the derivative of the function with respect to theta. If you notice, this function is product of two functions, so we can apply product rule. If we have two functions product, then derivative is first function's derivative times second function as is plus first function as is times the derivative of the second function. So that's your product rule. That's what we're going to apply here. H derivative is the derivative of the first function times the second function as is plus theta square, the derivative of the second function. Theta square's derivative is 2 theta using the power rule times sine theta as is plus theta square, derivative of sine theta is cosine theta. And really, there's nothing much to do, so that's about it for your answer. You can't really simplify any further. Let's do another example. This is f of x is equal to x squared times sine x times tangent x. So if you see carefully, this is actually three functions product. So still product functions kind of applies, but you just have to do it 3 times. So first function's derivative, second function, third function as is. Let's write it down. So it's generalization of your product rule. Derivative of the first function times second function as is third function as is plus the first function as is derivative of the second function times the third function as is plus first function second function times the derivative of the third function. Now we apply the rules. Derivative of x square using the power rule is 2x sine x tangent x plus x square. Derivative of sine x using the formula is cosine x times tangent x plus x square sine x times derivative of tangent x is secant square x. Now if you notice, there is x in each of the terms, but actually sine x is in the first and the last term, but I can write it one more time and show you that actually sine x is also in all of the terms. X square cosine x tangent x can be written as sine x by cosine x, okay, plus x square sine x secant square x. Now if you notice, x is in each of the terms and also sine x is in each of the terms. So basically what I'm saying is I can factor out x and sine x. What's left inside? Also I notice that this cosine can be divided by each other, will be just 1. So what is left in each term? The first term, x sine x went out, only 2 tangent x is left, plus second term, from x square x went out, just x left, and sine x went out. That's it. There's no cosine, that cancelled. In the last term, from x square 1x went out, sine x went out. We are only left with secant square x. This is your answer. Using your formulas and factorization. Okay. Let's do one more example. Y is given to be sine theta divided by 1 plus cos theta. You need to find dy by dx. That is your problem. Now this y is into the quotient rule. So I'm going to write your quotient rule here on the side. If we have y is equal to f by g quotient, then derivative is denominator square, numerator as is, derivative of numerator times denominator minus numerator as is, derivative of the denominator. So let's see if we can use this. Y prime is equal to square of the denominator, derivative is with respect to theta, remember here, numerator times denominator as is minus numerator as is times the derivative of denominator. Okay, let's figure this out. Derivative of sine using our formula is cosine theta, 1 plus cosine theta minus sine theta. Derivative of 1 is 0. We don't need to write it. Plus derivative of cosine is negative sine theta. Okay. Now, when you simplify, this cos theta can multiply with inside, FOIL inside. Let's write 1 plus cosine theta whole square. Cosine theta times 1 is cosine theta plus cosine theta times cosine theta is cosine square theta. Negative times negative positive sine square theta. Now, what do you think this is? You guys should remember your trig Pythagorean identity. Cosine square theta plus sine square theta is equal to 1. So that means what I'm saying is this thing can be replaced as 1. Let's write that down. Cosine theta plus 1 divided by 1 plus cosine theta whole square. Now you notice this thing is exactly same as this. So at least one power can cancel. What I'll be left with? 1 by 1 plus cosine theta. That is your answer.